Hello student, good morning. I am Dr.A.J. Kumar Sinha, Professor of Chemistry. Today I am going to start new chapter, Biomolecules. Biomolecules. What is biomolecules? It is the harmonious and synchronous progress of chemical reaction in body which leads to life. This is an important statement for biomolecules. It is harmonious and synchronous progress of chemical reactions in body which leads to life. A living system grows, sustains and produces itself. The most amazing things about a living system is that it is composed of non-living atoms and molecules. The pursuit of knowledge of what goes on chemically within a living system falls in the domain of biochemistry. Living systems are made up of various complex biomolecules like carbohydrates, proteins, nucleic acids, lipids, etc. Proteins and carbohydrates are essential constituents of our food. These biomolecules interact with each other and constitute the molecular logic of life processes. In addition, some simple molecules like vitamins and mineral salts also play an important role in the functions of organisms. Structures and functions of some of these biomolecules now I will discuss. Here you must know the living system. Living system is that it is composed of non-living atoms and molecules. Very, very important point. Living system is that it is composed of non-living atoms and molecules. Correct? The pursuit of knowledge of what goes on chemically within a living system falls in the domain of biochemistry. Living systems are made up of various complex biomolecules like carbohydrates, proteins, nucleic acids, lipids, etc. Proteins and carbohydrates are essential constituents of our food. These are called biomolecules. Carbohydrate, protein, nucleic acids, lipids. These are called biomolecules. These biomolecules interact with each other and constitute the molecular logic of life processes. Now I am going to discuss about carbohydrates. This is the biomolecules. Carbohydrates are primarily produced by plants and form a very large group of naturally occurring organic compounds. Carbohydrates are produced by plants, mainly it is produced by plants and form a very large group of naturally occurring organic compounds. Some common examples are cane sugar, glucose, starch, etc. Most of them have a general formula CxH2O whole Y. CxH2O whole Y. Okay, CX and H2O is whole 5. Okay, and were considered as hydrates of carbon, from where the name carbohydrate was first derived. General formula for carbohydrate is Cx, X may be 1, 2, 3, 4, and H2O whole 5, H2O whole Y. Y may be again 1, 2, 3, 4, 5 like that. Correct? This is a general formula for carbohydrate. Okay. But I will give you some example where this formula will not follow. Okay. And this due to this CxH2O whole Y, that is actually carbohydrate. Carbo word came due to the carbon, and hydrate word came due to H2O. Correct? Now example I am telling you that glucose, its chemical formula is C6H2O whole 6, C6H12O6. Then here C6, here X is equal to 6 and H12O6. Then here H12O6. Then this is a fitting the H2O formula, H2O whole Y. Then here outs Y is equal to here 6. H2O, if you multiply by 6, then you will get C12O6, H2O whole 6. Correct? Then C6H2O whole 6. This is fitting the formula CxH2O whole Y. Then this is the glucose formula, C6H12O6 fits into this general formula C6H2O whole 6. But all the compounds which fit into this formula may not be classified as carbohydrates. Some exception is there. All the compounds which fit into this formula may not be classified as carbohydrate. As for example, acetic acid CH3COOH. This fits into this general formula C2H2O whole 2, CH3COOH. You can write like C2H2O whole 2, but is not a carbohydrate. Means this formula always it will not fit. Okay. Similarly, ramenose C6H12O5. C6H12O5 is a carbohydrate but does not fit in this definition. CxH2 whole 5, that this is not actually, some exception is there. C6H12O5 is a carbohydrate but it is not fitting in this formula CxH2O whole Y. Correct? A large number of their reactions have shown that they contain a specific functional group. I am talking about C6H12O5, that is called ramenose. It is a carbohydrate but not fitting the formula. Correct? And but reaction reaction, a large number of their reactions have shown that they contain a specific functional groups. Chemically, the carbohydrates may be defined as optically active polyhydroxyaldehyde or ketone, or the compounds which produce such units on hydrolysis. Here important point you should understand, carbohydrate may be defined as optically active polyhydroxy aldehyde or ketone, or the compounds which produce such units on hydrolysis. Optically active compound, that is it will rotate the plane polarized light. Solution of the carbohydrate will rotate the plane polarized light. That's why it is called optically active polyhydroxy. That is carbohydrate, you can tell polyhydroxyaldehyde or ketone, or the compounds, any compounds which produce such unit on hydrolysis. Okay. Some of the carbohydrates which are sweet in taste are also called sugars. Correct? You should remember, all carbohydrates are not sweet. Correct? But some carbohydrates which are sweet in taste is called sugars. Okay. Some of the carbohydrates which are sweet in taste are called sugars. The most common sugars used in our home is named as sucrose, whereas the sugars present in milk is known as lactose. Lactose is present in milk, question is asked. And also sugar which we are using in our home, that is called sucrose. Correct? Then carbohydrates are, this I told you that some carbohydrates are sweet in taste and is called sugar. The most common sugar used in our home is named as sucrose, whereas the sugar present in milk is known as lactose. Carbohydrates are also called saccharides. You remember, carbohydrates are also called saccharides. What is the meaning of saccharides? Then this saccharides word came from the Greek word saccharon, S-A-K-C-H-A-R-O-N, saccharon means sugar. Now I will discuss classification of carbohydrate. Carbohydrates are classified on the basis of their behavior on hydrolysis. They have been broadly divided into three groups. First, monosaccharides. Second, oligosaccharides. Third, polysaccharides. Then here important point is that carbohydrates are classified on the basis of their behavior on hydrolysis. Okay, and these are divided into carbohydrate have been broadly divided into three groups. First is monosaccharide, second oligosaccharide, third polysaccharides. Now I will tell about the monosaccharides. A carbohydrate that cannot be hydrolyzed further to give simpler unit of polyhydroxy aldehyde or ketone is called a monosaccharides. Generally, carbohydrates on hydrolysis, it will give polyhydroxyaldehyde or polyhydroxyketone, and if on hydrolysis a carbohydrate that cannot be hydrolyzed further to give simpler unit of polyhydroxyaldehyde or polyhydroxyketone is called a monosaccharides. Means further it will not hydrolyze to give a simpler unit of what? Polyhydroxyaldehyde or polyhydroxyketone. About 20 monosaccharides are known to occur in nature. In nature, 20 monosaccharides are known, okay, to occur in nature. Some common examples are glucose, fructose, ribose. These glucose and fructose, further it will not hydrolyze. Correct? Glucose, fructose, ribose, this further it will not hydrolyze. That's why it is called mono. Mono means single, one, monosaccharides. Now come to the oligosaccharides. Oligo, carbohydrates that yield between 2 to 10. Carbohydrates that yield 2 to 10 monosaccharides units on hydrolysis are called oligosaccharides. Limitation is there. More than 1 means 2 to 10, maximum 10, minimum 2. 2 to 10, between 2 to 10, maybe 3, maybe 4, 5, 6, 7, maximum 10. Then that carbohydrates are called oligosaccharides. Okay. Carbohydrates that yield 2 to 10 monosaccharides unit on hydrolysis are called oligosaccharides. They are further classified as disaccharides, trisaccharides, tetrasaccharides, etc., depending upon the number of monosaccharides they provide on hydrolysis. Okay, how many monosaccharides they are giving on hydrolysis, accordingly name is given: disaccharides, trisaccharide, tetrasaccharides, depending upon the number of monosaccharides they provide on hydrolysis. Okay, because minimum it starts from the 2, maximum 10, then 2 to 10, then 2 again further can hydrolyze. 2 can further hydrolyze and can give 2 monosaccharides. If 3 are there, then it will give on further hydrolysis 3 monosaccharides. If 4, then 2 means that is called a monosaccharides. If they are providing 3 monosaccharides they are providing, then it is called a tri-monosaccharides. If it is giving 4, it is called tetra. Correct? Like that way, penta, hexa, hepta, octa, like that way name will be given. Okay, like disaccharides, trisaccharides, tetrasaccharides. Correct? And the 2 monosaccharides units obtained on hydrolysis of a disaccharides may be same or different. This again important point. The 2 monosaccharides units obtained on hydrolysis of a disaccharides may be same or different. For example, sucrose on hydrolysis gives 1 molecule each of glucose and fructose, whereas maltose give 2 molecules of glucose only. Then this is the example of disaccharide. Disaccharide may give same or different monosaccharides. The two monosaccharides units obtained on hydrolysis of a disaccharides may be same or different. For example, sucrose is a disaccharide. On hydrolysis gives one molecule each of glucose and fructose, whereas maltose it is also disaccharide, gives two molecules of glucose only. Now come to the third, polysaccharides. Poly means many. Polysaccharides, carbohydrates which yield a large number of monosaccharides. Large number. Carbohydrates which yield a large number of monosaccharides units on hydrolysis are called polysaccharides. Only on hydrolysis they are giving mono, di, tri, poly, whatever be. Hydrolysis is must. Then carbohydrates which yield a large number of monosaccharides units on hydrolysis are called polysaccharides. Some common examples are starch. Starch is polysaccharides. Okay, glycogen. It is also example of polysaccharides. Gums, Gums, gums. It is also polysaccharides. Okay, polysaccharides are not sweet. You remember, a starch is not sweet, but it is a carbohydrate. Cellulose is not sweet, but it is also carbohydrate. Glycogen, it is not the sweet, but it is also carbohydrate. Gums, it is not the sweet in taste, but gums are carbohydrates. Polysaccharides are not sweet in taste, hence they are also called non-sugar. Non-sugar means you should not understand that it is not carbohydrate. This is also carbohydrate, but it is not sweet. The carbohydrates may also be classified as either reducing or non-reducing sugar. Correct? This is again important point. Classification. Carbohydrates may also be classified as either reducing or non-reducing sugars. All those carbohydrates which reduce failing solution and tolerance reagent are referred to as reducing sugar. Just what is the reducing sugar? That I have told you, again I am telling you, all those carbohydrates which reduce failing solution and tolerance reagent. Actually, failing solution and tolerance reagents are oxidizing agent, you remember. But now carbohydrates which reduce failing solution and tolerance reagents are called reducing sugars. All monosaccharides, whether aldose or ketose, are reducing sugars. You remember, all monosaccharides, monosaccharides may be aldose or ketose. Aldose name is due to aldehyde. Aldehyde group, if it is present in the monosaccharides, then that monosaccharide is called aldose. And when ketonic group is present in monosaccharides, then it is called ketose. Okay, you remember this thing, very very important point I have told you. In disaccharides, this I told about the monosaccharides, that this monosaccharide may be aldose or ketose, and both are reducing sugars. Correct? monosaccharides, whether aldose or ketose, are reducing sugar. Correct? Examples already I have told you. All monosaccharides like glucose. Correct? Monosaccharides example I told you, glucose, fructose, ribose. Then all are reducing sugar. Now come to the monosaccharides, reducing sugar I told you. Now in a disaccharide like sucrose, sugar, ordinary sugar which we are using in our home. In disaccharides, if the reducing group of monosaccharides, that is the aldehydic or ketonic groups, are bonded, they are non-reducing sugars. You remember, disaccharides are non-sugar. Example is sucrose, what we are using daily in our home, that is the non-sugar. Okay, it will not reduce the these things, both oxidizing agent like failing reagent and Toll's reagent. It will not reduce. Okay, sucrose will not reduce. Then actually sucrose is disaccharides. If the reducing groups of monosaccharides, that is the aldehydic or ketonic group, are bonded, they are non-reducing sugars. Example is sucrose. On the other hand, sugars in which these functional groups are free are called reducing sugars. For example, maltose and lactose. This is in there are two cases in disaccharides. First case is that if reducing groups of monosaccharides, reducing group, that is the aldehydic or ketonic group, are called this group, aldehydic and ketonic groups, if these two groups are bonded, these are called non-reducing sugars. If it is bonded, aldehydic and ketonic group are bonded, then these are called non-reducing sugars. Example sucrose I told you. Now on the other hand, sugars in which these functional groups are free are called reducing sugars. For example, maltose and lactose. Correct? On hydrolysis, disaccharides will give these things. Disaccharides will give monosaccharides. Then they will give monosaccharides, but if they are free, fully free, then it is called reducing sugar. And if they are not free, means are bonded, then these are called non-reducing sugars. If bonded, means they are not free. Not free means non-reducing sugar. And if it is free, then reducing sugars. Then example of reducing sugars is maltose and lactose, which you will get by disaccharides. Now I will go little details about monosaccharides. Monosaccharides are further classified on the basis of number of carbon atoms and the functional group present in them. Then only two functional groups may be present, only two. Then that is generally ketonic group or aldehydic group. Okay. Then on that basis and on number of carbon, monosaccharides are further classified. Monosaccharides are further classified on the basis of number of carbon atoms and the functional group present in them. if a monosaccharide contains an aldehyde group, it is known as aldose. And if contains a keto group, means ketone, CO, it is known as ketose. Number of carbon atoms constituting the monosaccharide is also introduced in the name. As I will tell you now, that by some example I will tell you, then quickly you will understand. Suppose carbon number is 3, and if carbon number is 3 and aldehyde group is attached, correct? Then because carbon number is 3, it is monosaccharide, but carbon number is only 3, then it is called triose. Tri means 3, OSE, triose. Okay. And if you can say in this triose, 2 types are possible. In triose, if aldehyde group is attached, if carbon is 3, triose is there, but in that triose, aldehyde group is present, then it is called aldotriose. Aldo you have to add, triose adjective, aldotriose. And if ketone group is present in triose, if ketone group is present, then its name will be keto triose. Name will be the same. Triose name will be the same. If aldehyde group is present, then you can tell aldo triose. If ketonic group is present, then you can tell keto triose. Aldo and keto, remember. If 4 carbons are present, then its name will be same way, tetrose. Tet means 4, T-E-T. Tet means 4, tetrose. Okay, T-E-T-R. O-S-E like this way. O-S will be there, T-E-T-R, tetra means 4. Then this tetrose, if aldehyde, it contains aldehyde, then it will be called aldo tetrose. Aldo tetrose. Tetrose will be the same. Only aldo will you have to add, aldo tetrose. If a ketonic group is present, then its name will be keto tetrose. Keto tetrose. Like that way, if 5 carbons are there, then it will be called pentose. P-E-N-T. Pent means 5. If 5 carbons are there, then general term will be pentose. These are the carbohydrate. Then here pentose, 5 carbons are there, and OSE as it is. Every time OSE will be the same. Then pentose. And if aldehyde group is present, then it will be called as aldopentose. Aldopentose. And if keto group is there, ketonic group is present, then it is called ketopentose. Keto, one time aldo you have to add if aldehyde is present, other time keto you have to write if ketone is present. Then it is called aldopentose if aldehyde is present, and ketopentose if ketone is present. Now, if 6 carbon is there, then hexose, H-E-X, hex means 6, hexose. Then if aldehyde group is present, then aldohexose. And if ketone group is present, then ketohexose. Like that way, if 7 carbons are present, then it will be heptose. H-E-F-T, hept means 7, heptose. Then if in heptose aldehyde is present, then same way, aldoheptose. And if ketone is present, ketoheptose. Okay, these is a very, very important to understand the, you can say, monosaccharides. These are the different types of monosaccharides I have discussed. Now I am going to discuss glucose. Is very, very important. Okay. Glucose is common in carbohydrate. Glucose occurs freely in nature as well as in combined form. It is present in sweet fruits and honey. Main source is sweet fruits and honey. There you will get glucose. And ripe grapes also contain glucose in large amounts. Ripe grapes, not unripe, ripe. Ripe grapes also contain glucose in large amounts. Then how will you prepare? How will you prepare the glucose? Then I am telling you preparation of glucose. Then first preparation from sucrose. Sucrose is disaccharide. Then you can prepare it from disaccharide, means sucrose. And cane sugar, another name of sucrose is cane sugar. You might have drunken also cane sugar. In that sucrose is there. And sucrose is example of disaccharide. Then you can prepare glucose from sucrose. If sucrose is boiled with dilute HCl, if sucrose solution is boiled with dilute HCl or H2SO4 in alcoholic solution, it will give you glucose and fructose. 1 mole of glucose and 1 mole of fructose, both it will give. Means C12H22O11 plus H2O. Here H2O function as catalyst, H plus. H2O it will provide H plus. And its H2O must be in large quantity. It will function as a catalyst. H plus is required. Correct? And sometimes OH is also required. Alcoholic solution, HCl or H2SO4, both are required in alcoholic solution. Then sucrose C12H22O11 plus H2O in acidic medium, it will give 1 unit of glucose, 1 unit of fructose. Means 1 molecule of glucose, 1 molecule of fructose. Correct? Here C12 was there, then glucose 6 carbon, fructose 6 carbon, and hydrogen was 20. Then now in presence of H2O reaction is going on. Then 22 plus this 2, 24 hydrogen. That's why in glucose and fructose hydrogen is 12. And glucose, sucrose C12H22O11. This is the formula for sucrose. Then oxygen is only 11. Then H2O has 1 oxygen. That oxygen it will take. Means H2O is going to be absorbed by sucrose. Then now total number of oxygen became 12. O11 was there plus 1 oxygen from water. Then now you got 12 oxygen. Then you can divide into 6. That's why now you got C6H12O6. Again C6H12O6. Then one is glucose, other is fructose. Then what are the differences in glucose and fructose? Then in glucose, aldehyde group, CHO group is present, and in fructose, ketonic group is present, COO, carbonyl group is present. Okay. Now another preparation I am telling you from a starch. Then a starch, what is the starch? It is polysaccharide, starch, cellulose, correct? Glycogen. These are the example of polysaccharides. Okay. Then gums, GUMS, gums is also example of polysaccharide. Then you will get glucose from a starch. Okay. Then commercially glucose is obtained by hydrolysis of a starch by boiling it with dilute H2SO4. But you have to maintain temperature at 293 Kelvin. 293 Kelvin means 120 degree Celsius. 273 Kelvin, you minus it, 273, then 120 you will get degree Celsius, and some pressure you have to apply. Then reaction will be same. But here starch formula or cellulose formula, you should remember both are formula is same. Always you remember formula for starch or cellulose. What is the formula? C6H10O5. C6H10O5. H10O5 means water ratio you have to keep 2:1, and that ratio. If oxygen is 5, then hydrogen should be double, 10. Then C6H10O5 whole N, because it is the polysaccharides, whole N. Now because N is there, total whole N is there, then NH2O you require, because one H2O will be required for one C6H10O5, one H2O. Then there are N and a small n, then a small n H2O is required. Means if suppose n is 5, then 5 H2O you require. If n is 10, then 10 H2O you require. That's why n is same in both. Then reaction is C6H10O5 whole n plus NH2O. Then this reaction will take place in the presence of acid medium like H2SO4, and temperature you have to maintain 393 Kelvin under pressure. Then it will give how many glucose? Then n number glucose will get. Means C6H12O6 glucose you will get n number, because here H10O5 is there and you have taken H2O, then H10 and here H2, 2H, total 12, and O was 5, now 1 oxygen, then now became 6 oxygen. That's why, and total is N, whole N, hence you will get N6H12O6. Means water is required. Water is required in excess, or a ratio will be that is the N. What is the N? Number of these things, polysaccharides. How many numbers are there? N. In the same number water is required. Here I want to tell you very important things. After eating, you require water. You drink water. Why? Then now you can understand. Because generally you will eat a starch. Either starch means here carbohydrate in the form of rice or wheat. Then starch are more there in both. But comparatively in rice, starch are more than wheat. Wheat is little less and rice is more. Then after eating, after half an hour or 45 minutes, 1 hour like that, you will feel thirsty. Then major reason of becoming thirsty is this here only. This is the only, because now chemical process should go. Then for that process you require water. This process only, starch plus H2O. Excess water you require. Only then you will get the glucose, and glucose will go to the blood and you will get the strength. You will get the strength to do the any type of work. Then if you will not drink water, you will feel uneasiness and this process will stop. Then If process will stop, you will not get the glucose in blood, and then you will not get the strength. You will become very weak. And just to maintain this reaction, that is called hydrolysis, this process should not stop. That's why you require water. You feel thirsty, correct? Just after the eating, 30 minutes, 40 minutes, 45 minutes, sometimes you drink taking food time only, but better you take at least after 1 hour. Then actually starch will break into pieces. Starch is a bigger unit, then it requires 20-25 minute times to convert into the glucose. But before drinking, without drinking water, it will not convert to glucose. Reaction you are understanding. That is the starch plus water, that will give glucose. C6H10O5 whole N, C6H10O5 whole N plus NH2O. It will give NC6H12O6. But this reaction requires acid medium H plus, and temperature is required 393 Kelvin, and atmospheric pressure around 2 to 3 atmospheric pressure. Then here some reaction, this is actually outside also, this I told in our body, but that time it requires gymase, correct? Diastase and gymase, you require biocatalyst. What you are telling? Catalyst. Biocatalyst. Catalyst outside. That catalyst, if you are using in the body, catalyst of the body is called biocatalyst, and that is called enzyme. Okay. Then in body, diastase and gymase is required. Okay. And here only I want to tell you why you feel sleepy after taking the food. What will happen, that actually sometimes reaction will take in presence of oxygen, sometimes in absence of oxygen, correct? Then aerobic or anaerobic. If a reaction is going in presence of oxygen, it is called aerobic, and without, in the absence of oxygen, it is called anaerobic. Aerobic. AEROBIC. Then in body, this reaction takes place anaerobic, in absence of oxygen. But here, this after getting the glucose, this is the first process. Okay, that this after getting glucose, one more step will be there quickly, soon, that this glucose will convert to ethyl alcohol plus carbon dioxide. This glucose will break into 3 parts. First, ethyl alcohol. Second, carbon dioxide. Third, it will produce heat. Due to that heat, you will feel, I can say, these things hot. Sometimes you will feel warm. After taking food, you will feel warm due to the release of this heat, and you release carbon dioxide from your nose. Due to this reaction, by this reaction, carbon dioxide it is releasing. Due to that, carbon dioxide is coming out. But there always, whenever carbon dioxide will come, then there that carbon dioxide will be warm, because both reactions are taking 3 products at a time. You are getting ethyl alcohol, carbon dioxide and heat. Then carbon dioxide and heat is coming together. Sometimes water vapor may also come, because due to the other reaction also, in that reaction H2O is formed. Aerobic reaction, when it will take place, that time you will get water, H2O vapor, that also it will come through the nose. Then sometimes vapor also will get water vapor, and carbon dioxide will come and it will be warm. Then little warmness is going, carbon dioxide becomes warm and then it is going. Actually it is the combustion reaction in our body. And why you are feeling sleepy? Because ethyl alcohol is formed. Ethyl alcohol is formed, correct, in a natural way. People will drink wines, correct, wines. That is not required. Already in our body, in a natural way, it is forming. That's why you feel sleepy. If you eat more rice, then it will produce more alcohol and you will feel more sleepy. Okay. Then I told the reason why you require water. I told you reason why you want to drink water after food. And other water has many role. One major role I told you. Actually it dissolves all the food what you have eaten, and only in the solution form all reactions in a body takes place, not in solid state. For that purpose water is also required. Okay. Then all I told you why do you require water after food. And second, actually body maintains also temperature, then in that also water is required, correct, in summer or in winter. Actually in winter body water regulates the temperature. In winter season what happens? In winter outside temperature will be less than body temperature. Body temperature always maintains around 37.5 degree Celsius, but outside temperature will be less. You know that it will go to the 10, 15, 20. Then from our body temperature will go outside, but you have to require to maintain that temperature only 37.5, correct. In any situation, either you are in border in minus 40 degrees, wherever you will be there, that has not very big thing. But if you are maintaining your body with a special suit, correct, then your body temperature will be 37.5 only. Okay. Then here that water plays a big role, just they will excess heat, because always outside temperature, inside temperature, they want to equilibrium they want to maintain. That's why heat from our body should go outside. For that purpose in winter more urination, because that will go, the extra heat will go through urine. Okay. And in summer you drink more water, because reverse case, outside temperature will be more and body temperature will be less. Outside temperature, suppose it becomes 40 degree, 45 degree, then to maintain the body temperature, because more sweat will come from your body due to the heat, then in body water will be less. Then to maintain the water body you require more water. That's why you drink more water in summer. Then I told you this due to the one reaction, how this important reaction is this. You can understand many, you can say reason why you are drinking water, correct, after food, why you feel sleepy, why carbon dioxide is coming, why water vapor is coming from the nose, all the things you understood. Okay. Then now these things. Today is the first day for this chapter. Now I am stopping only here. Next class I will continue. That is the derivation of a structure of glucose. Because it has many structure. Then that structure of glucose I will discuss in the next class. Thank you.